is we are going to finish the final exam review. We started it on Monday and we got through number 14. So we're going to start with number 15 today, right? We got through 14. Yeah. So 15 is find the zeros of the polynomial function and state the multiplicity of each. So the function is f of x equals 3 and then x plus 8 squared and x minus 8 to the third. So when I'm finding zeros of the function, I'm looking for, remember your zeros always come from the factors that have the x's, okay? So you would just find any factor that has an x and set it equal to 0. And then solve those equations for those x's, which just means you'll subtract 8 on this one to get x equals -8. On the other one, you would add the 8 to get x equals +8. So those are the two zeros of the function, and it also wants you to name their multiplicity of each of these zeros. And remember where the multiplicity comes from. It comes from the exponents of each of the factors. So -8 is a 0, and it has multiplicity of 2, or multiplicity is 2, however you want to state it. And +8 is a 0, and its multiplicity is 3. All right, number 16. So this one, I want you to graph this function. Okay, so let's look at this function. Okay, you can put it in your y equals and graph it on your calculator. But just to refresh our memory about what we talked about in this section, the function is g of x equals -x x plus 2 squared, x minus 1 squared. Okay, so here's what I know about this function. First of all, remember talking about end behavior. Okay, remember the end behavior rules. If your leading term, okay, let me just draw them out first. So those were the 4 different kinds of end behaviors that your graph could possibly have, right? Depending on where we get these are the leading terms. So we need to think about this function like it's all the way multiplied out and what the leading term would be, right? If I FOIL this, since it's x plus 2 squared, that would give me an x squared. Same here, this would give me an x squared. And if I multiplied those together, I would have x to the 4th. But then I also have this -x. So if I would have distributed that -x to that x to the 4th, what am I going to end up with? I would end up with -x to the 5th as my leading term. This is what is going to give me my end behavior of this graph. So first of all, the exponent is odd, which takes me over to the odd end behaviors. And the term is negative, which means it's going to have this end behavior. It's going to start up on the left and then travel down throughout the graph. which if you're looking at your multiple choices, that would only be B, A, and C, right? Starts at the top, travels down throughout the graph. These other two are odd in behaviors, but they're positive, right? Since they go up throughout the graph. So I'm down to B and C as my options. I can also tell where the x-intercepts of this graph would be. So let's see where all three of these factors have an x. So they're all going to create an x-intercept, right? So this one, I divide by -1 to get that x by itself. I would get x equals 0. So there's going to be an x-intercept at 0. Track 2's here. There's also going to be one at -2. And this last factor, when I add the 1's to both sides, there's also going to be an x-intercept at +1. Now, remember, the end behavior got us down to the options B or C. Now, these two graphs are so very similar. And I'm hoping, the questions just come up randomly. I don't put the questions on there. They come up randomly. So what I'm looking for here, and you'll look how similar they are. I'm looking for those x-intercepts, which means at 0, -2, and +1. When you're looking at the difference between B and C, and again, they're so similar. If I'm looking at B, and you should have a magnifying glass next to this problem, it does touch at -2. And +1. This one on C, you'll notice if you look real close, it doesn't, there's my -2, and it doesn't touch it there, right? It's real close to it, but it looks like these two are kind of flip-flop. It looks like on C, it touches at +2 and -1. Okay, so just be real careful when you're looking for those x-intercepts. Okay, number 17. Find the vertical asymptotes. Remember where vertical asymptotes come from. They are created by the zeros of the denominator that are not also zeros of the numerator. So our function is this: h of x equals x squared minus 100 over x minus 2x plus 7. So the first thing you want to do is find the zeros of the denominator. And they even were nice enough to actually put them in its factored form for us. So all I have to do is set the factors equal to 0 and solve them for x's. So here I would add the 2 to both sides. So x equals 2. Here, subtract the 7 from both sides. So x equals -7. So these are where my vertical asymptotes are going to occur, as long as neither one of those are also zeros of the numerator. Now, the numerator is not in factored form, but if I did factor that, it would be a difference of perfect squares, right? So it would be x plus 10, x minus 10, which means this 0 would be -10, that 0 would be +10. So the zeros in the denominator don't match the zeros in the numerator, so I don't have to worry about that. So these are two true vertical asymptotes. Just be careful, because look at what one of the options is. It also has 2 and -7, but it's y equals. Remember, vertical asymptotes are always x equals, so don't get fooled by the y equals ones. Number 18. So f of x equals negative 5x plus 9. G of x equals negative 5x squared plus 9x minus 5. And we are finding the function value for g of f of 3. So this was a composition of two functions. When you have a composition of two different functions, finding the function value, you always find what's in that position first. Okay? Because sometimes it'll say g of f, sometimes it'll say f of g. It doesn't matter. You always find what is in this front position first. So I need to find what is f of 3, which tells me to go to my f function and replace its x with that 3. So if I replace this x with the 3, I'll have negative 5 times 3 plus 9. Do the math. So negative 15 plus 9, which gives me negative 6, and that's halfway there, right? I've only found f of 3. I need to find g of f of 3. So now I bring down the g, and I find g of whatever that last answer was. So I'm finding g of negative 6. Which tells me go to my g function this time and replace its x's with negative 6's. So if I do that, I'll have negative 5 times negative 6 squared plus 9 times negative 6 minus 5. You can literally just put that whole thing right there in your calculator, exactly how it's written. Okay, if you worked it out step by step, you would need to do the order of operations would tell me to do that exponent first. So I'd have negative 5 times, not negative, positive 36, which would give me negative 180. Then I have 9 times negative 6, which is negative 54. Bring down my negative 5, and if I combine all those numbers together, it gives me negative 239. Okay, number 19. All right, another composition of functions. This time my first function is f of x equals negative 3x plus 7. My second function is g of x equals 2x plus 8. This time it wants me to find g of f of x. So same process as the last problem. Find whatever is in this position first. So I am finding f of x. It already tells me what f of x is, right? Or in other words, it's saying go to your f function and replace the x with x, which means don't change it. So f of x equals negative 3x plus 7, and I can't simplify that, right? I can't combine those like I could put the numbers together on that last problem. I still need to bring down this g. And what are you finding g of? Just like the last one, I'm finding g of whatever my last answer was. So I'm just finding g of negative 3x plus 7, which says go to your g function and replace its x with negative 3x plus 7. So I'll have 2. Replace the x with negative 3x plus 7 plus 8. And then simplify it. So I'll distribute this 2. So 2 times negative 3x gives me negative 6x. 2 times 7 is 14. Bring down the positive 8. And then 14 and 8 are like terms, so you can put them together. So you have negative 6x plus 22. All right, number 20. On number 20, the first thing it wants you to do is find out whether or not the function is 1 to 1. The function is f of x equals 3x minus 6. If a function is 1 to 1, it passes the horizontal line test. Remember the horizontal line test? It's pretty much the same thing as the vertical line test. It's just using a horizontal line. If your function, when you graph it, if you can draw a horizontal line through it and only touch it once, then it is going to be 1 to 1. If I graphed this by putting it in y equals and graphing it, I see it's just a straight line, right? So it doesn't matter where you draw a horizontal line on this, you're only going to touch that function one time. Okay, which means it is 1 to 1. And then it says, if it is 1 to 1, find its inverse. So the way we find the inverse is, first of all, just to rewrite the function. And instead of writing this f of x, write it as y, right? Because y and f of x mean the same thing. So y equals 3x minus 6. Now, here's the inverse part. You're going to invert the x and the y. You're going to switch their places. So this will become the x equals 3y minus 6. Once you switch the x and y, then you're going to get the new y by itself. Then that'll be the inverse. So you're going to add the 6 to both sides. So now you have 3y equals x plus 6, and then divide everybody by 3. So y equals x plus 6 over 3. There's your inverse. The way they write it is f to the negative 1 of x equals x plus 6 over 3. This right here is how you show that it's the inverse of the original f of x. So that's what that f to the negative 1 means. Number 21. Says graph this function f of x equals 4, and then the exponent is x minus 4, so 4 to the x minus 4 minus 3. So this is an exponential function. The original exponential function, just without any shifts, looks like this. So let's talk about where these are shifting this graph. Okay, can you put this in your y equals in your calculator? Absolutely. Okay, this is an inside number, which means it shifts it horizontally, opposite the sign. So that -4 is going to shift this to the right 4. The outside number, the number back here, is a vertical shift up and down. You go with the sign. So since it's -3, it's going to shift it down 3. So think about this shape being shifted to the right 4 and then down 3. And which one would that look like? Which one of these has been shifted to the right 4 and down 3? This A is the only one that has done that. Right? Right 4, down 3 would shift it over there. Okay, but you can obviously, you can also put that in your y equals to graph it. (22) gives you a logarithmic equation and asks you to convert it to an exponential equation. So log base 8 of 64 equals t. So if we're going from log to exponential, remember, if you're the base of the logarithmic equation, you're also going to be the base of the exponential equation. Okay? So this is going to be the base of your exponents. You're going to have 8. That's going to be your exponent. So 8 is going to be raised to the t power. Then it's going to be equal to whatever is in this position of the log. So 8 to the t equals 64. It doesn't even want you to solve it. It just wants you to rewrite it. (23) log x to the 8z over y to the 9th. It wants us to rewrite this in terms of sums and differences. So let's see, I'm going to have 3 separate logs since I've got 3 separate letters up there. Okay, so the ones in the top of your fraction will be turning into a sum, right? Because they're multiplied. Multiply turns into sum of logs. The one in the denominator is going to turn into a difference or a subtraction because divided by turns into difference of logs. So let's write it out like that first. So my first one will be log of x to the 8th plus another log. The second one up top is the z. And then remember, if it's in the denominator, it's going to be a minus log y to the 9th. But remember, you don't want to leave exponents in your logs, and you'll be able to tell because that won't be any of your answers. Where do these exponents come? They come down and they become the product of that log. So let's see, this will turn into 8 log x plus log z minus, bring down the 9, log y. Two more. Number 24. The population of a small country increases according to the function, and it gives you this function. B equals 2,100,000 e to the 0.05 t. Okay, T is measured in years. Then it wants to know how many people will the country have after 2 years. So where are you going to put the 2? In place of that T, and then just put it in your calculator. So in your calculator, you're going to have 2,100,000 e to the 0.05 times 2. And then it's going to give you a decimal. You're going to round it to the nearest whole number. So if you put it in your calculator, just like you see it on the board, replacing that T with a 2. And I look here, if I round it to the nearest whole number, I need to look at that first number after the decimal. Since it's a 9, it's going to round that 8 up to a 9, which will give me 232. All right, excuse me, 2,300,000. Excuse me, thank you. 320,859 once you round it up to that 9. Last one. The last one is solving an exponential equation, and depending on the equation that's given to us, that leads us to the method that we're going to use to solve it. Okay, the first method, which we like the most because it's the easiest and I don't have to log both sides, is if you can rewrite and you can make the bases of both sides of your equal sign be the same, that's what you want to do. So let's look at what we have. We have 4 to the 12 minus 3x equals 64. So in other words, if I can rewrite 64 as a number that has a base of 4, like 4 to some power, that's what I want to do. So let's see, 4 to the first gives me 4. 4 squared is 16. 4 to the third is 64. So I can rewrite 64 as 4 to the third power. So that's what I'm going to do. I'm going to have 4 to the 12 minus 3x equals 4 to the third, right? Because this is the same exact thing as saying 64. If you can rewrite your bases the same, then you can solve it by simply putting your exponents equal to each other. So I have 12 minus 3x equals 3. Again, I'm just putting my exponents here equal to my exponent there, and then solving it for x. So here I would subtract the 12. So negative 3x equals negative 9. Divide by negative 3. So x equals 3. Okay? All right, I got everybody online, everybody in here taken on roll.